All right, let's look at the theorem 2, fundamental theorem of isometries. Right, it states this: every isometry is the product of at most 3 reflections, and exactly 2 reflections if it is direct and not the identity, which means non-trivial. Right, and the corollary of this theorem 2 is a non-trivial, which means that it's not an identity map. Direct isometry is either a translation or a rotation, right? So this is just a corollary of a theorem 2, so you can use theorem 2 to make this conclusion, but this is given as homework. All right. So remember that theorem 1 tells you that if two isometries agree at the 3 known collinear points, then that is sufficient to conclude that those 2 isometries are actually identical. All right. So what we want to do is to verify, or I would like to demonstrate this theorem. So if you have an isometry, we can always, express it as the product of at most, 3 reflections. Right, so I'm going to use the GeoGebra to illustrate it. Right here. All right, so I drew random 2 congruent triangles, and let's say isometry maps one of the triangle to the other one. Right? Then if that's the isometry, what we can do is I'm going to show you that I'm going to do at most 3 reflections to match the one and actually to reflect it onto the other triangle. All right, so let's do that. All right, so first thing I would do is I'm going to probably do this. Here, I know that this guy is going to correspond to that one. So what I'm going to do is I'm going to draw a perpendicular bisector. So here, perpendicular bisector between this point and that point, right? So I'm going to use that to reflect it over here. So I'm going to do a reflection. So this is a reflection. So I'm going to reflect this triangle over to that. All right. So you can see that here we could actually match this, well, I guess map this vertex to the corresponding vertex. Now they're right on top of each other. All right, so we can match one, corresponding vertices by using one reflection. All right, then I'm going to do another one. So let's say I know that this one corresponds to that one. So I'm going to do another reflection. All right, so I'm going to draw a perpendicular bisector between those 2 guys. All right, and the beauty of this process is that here we know that this point is already matched. So by applying another reflection, we don't want to mess that up. But here, since this point is sitting on the line of reflection, which means that it's going to be a fixed point of that reflection, right? So I'm going to go ahead and reflect. So here, this one here reflected about this perpendicular bisector. All right, so this is 2 applications of reflections. All right, now you can see that their 2 vertices are already matched. Then we can match this one to the corresponding one. All right, so but you can just use the same thing. All right, perpendicular bisector. Oops, sorry, I messed that up. So we're gonna do a perpendicular bisector. All right, here again, the line of reflection contains actually both of these already matched points. So these are fixed points, so they're going to stay there. All right. Then we're going to do a reflection. All right. So we're going to reflect this guy about this line here. All right. Now you can see that it's perfectly matched here. right? So because we can match at least one vertex, sometimes you get lucky, you do one reflection, you match two of them, but we can at least match one of the corresponding vertices, a pair of vertices, by doing one reflection. And since there are only 3 points, so it's going to require at most 3 reflections. Right? So the combination, the product of those 3 reflections is going to be identical to the isometry that maps this triangle here to this second triangle. All right? So that is why every isometry is the product of at most 3 reflections. Right? That's it. I hope that this was clear.